Hi everyone, thanks for joining us. My name is Hunter Terry. I'm a coordinator at the Southeastern Center of Robotics Education. We are an office at Auburn University that focuses on expanding, promoting STEM education throughout the Southeast. So we do a lot of different things, but one of the things I do is helping best robotics teams get started. So this is going to be a three-part video series. We're going to talk about the control system in this video and how it works, what's in it, some basic tips on what you can and can't do with some of the parts, things like that. The second video, we're going to talk about how to actually plug things in. There's a lot of really specific ways to plug things in for best robotics, and if you don't already know, it can be difficult to sort of play around and find out. And it's also important that you do it the right way so you don't damage anything. So that's what we're going to talk about in the second video. In the third video, we're going to talk about some basic programming using RobotC. There are other programs out there, but I'm going to teach you how to use RobotC just because I believe, and we believe here at SCORE, that it is the best and easiest way to get started in best robotics. And maybe you can move on to other programs later. So that's how that series is going to go. Again, this video, we are talking about the best control system, the hardware, how it works, how you can use it, things like that. So let's jump into it. Here's a quick overview of some of the electrical components of the returnable kit. This doesn't have every single thing in the returnable kit simply because the returnable kit changes a little bit every year. I'm going to try to focus on the parts that you use every single year so that this is sort of a reusable thing, but also I'll hit on a couple of non-electric components as well, just to talk about what you can and can't do with them. The control system of your robot is the VEXnet control system. It is an older system created by VEX Robotics. I'm sure everyone is familiar with these if you've done best robotics before, but odds are this is your first time. So VEX Robotics is a large company that builds robotics solutions for classrooms and competitions and things like that. Anyways, the VEXnet control system, I've got one here with me. I'm going to be pointing out things throughout the video specifically. You know, you don't have to know the specifics of it, but you do know that the control system itself consists of the brain, the Cortex is what it's called, and the controller. So we'll talk more about that in the next few slides, and we'll go and move on straight to the Cortex. So the Cortex is essentially the brain of the robot. So what happens with this brain is you put power into it, you plug the battery straight into the brain, and you put inputs into it. You put things like your controller. You know, you're going to push buttons on the controller. You put sensor data into it. All sorts of things go into it. Those are sort of the three main ones. And then the Cortex decides, okay, I've got these inputs. I've got this programming. That's another thing I didn't mention that goes into it is programming. We've got this program. This program says that when I get this input, I should do this. So looking at this picture here, we have on the left side of the photo, we've got the digital ports, the digital ports over here. These digital ports and analog ports are where you get inputs, primarily at least. That is where you get inputs. The motor ports is where you get those outputs. So essentially on this left side of the brain, you are getting those inputs I'm talking about, as well as through the USB VEXnet key. On the right side, it's outputting, basically telling motors what to do. And it tells motors what to do by sending a certain amount of power to it, or sending a certain signal to the motor, in the case of servos, things like that. The most important thing that I want you to get from this little blurb right now is that these are not cheap. They're expensive, and VEX does still support them, but they are still hard to come by. So don't put your hub in the situation that they need to try and replace one. Don't put your school in the situation that they need to pay for one. It is not a cheap device, and it is also not that hard to not break. It's going to take some effort. These are really robust machines. Don't drill into it. Don't smash it with a hammer. Don't plug in the battery to ports it's not supposed to. Things like that. I'll talk about a couple specifics with how you plug in motors later that can potentially damage it, and things you can do with motors that'll damage it, but we'll get to that shortly. Next up is the controller. So the slide here says it's a PlayStation style controller. I think that's a little specific. Pretty much every video game controller has this same layout, or at least close to this layout. I know some of you people who love Xbox or PlayStation might get upset by that, but the fact of the matter is you're going to have the same controls. So the first thing you have is 2 joysticks. Pretty much every video game controller has 2 joysticks. These 2 joysticks both have 2 axes each, so you can program the different directions on the joysticks to do different things. If you look at the joystick itself, it's going to have these little labels next to the joysticks that tells you what number the axes are. That's really helpful when you're programming because it's important to know which axis you're programming. Next up, you've got 8 buttons across the top. They're sort of in this up, down, left, right format. And if you look at the buttons, they're pretty clearly labeled with U, D, L, R, as well as the number for each set of buttons. So that's how you're going to identify them. So if I'm pushing this button right here, that is 7D on that left side. So yeah. Next up, you've got these front side buttons. You might call them shoulder buttons. You're going to use your index finger and middle finger for those. These shoulder buttons are similar. They're pretty clearly labeled with an up and down, sort of hinting you towards what you might use that for, maybe an arm or a claw or something. But yeah, so you've got those shoulder joysticks. You've also got this USB port on the bottom. In that USB port, you can plug in your Wi-Fi key, which we'll talk about in a second. You can also plug in a USB tether. That's how you sort of tether it to your Cortex. You tell it this is the device you're working with. That's also how you can work with programming and things like that. We'll talk more about how you plug things in the second video. You've also got your programming interface. Again, we'll talk more about that in the next video. And a power switch. Pretty obvious. Make sure your power switch is on when you're starting a match. I know it sounds silly for me to remind you that, but you'd be surprised how many times that happens. Of course, also it does use 6 AA batteries. It can be normal batteries, but your hub should provide you with rechargeable batteries, so you don't have to worry about buying more or running out or anything like that. Yep. Final thing to think about, there is a 3-axis accelerometer built into the controller. So an accelerometer is a device that gives you, especially 3-axis one, it gives you 3 different things. It can tell you rotation, it can tell you movement. So it is a lot more advanced, but you can program your controller to do things when you shake it, or you can program to use it as a tilt control, things like that. A lot of the times, especially in VEX Robotics, there's not a lot of time to either build a robot that would be useful for, or figure out the programming for it. And I'm not going to teach you the programming because it is pretty complex. However, it is there if you want it. If you've been doing VEX a couple years, if you're really interested in learning programming, I'd be glad to point you in the right direction. But that is the last part of the controller. The next thing are these USB tethers. The USB tethers essentially use Wi-Fi. It happens to be the exact same band, which is 2.4 gigahertz of most Wi-Fis. Now there are 2 different bands. You probably hear about 5 gigahertz as well. There are many differences, but 2.4 gigahertz has more range, things like that. Most events, most competitions, most schools are going to have 2.4 gigahertz Wi-Fi running throughout the building. So it is very possible that there can be interference problems. One of the main problems we have, especially at South's Best, is cell phone hotspots. When you have thousands of people in a room and everyone wants to turn on their Wi-Fi hotspot, there's only so many bands of radio signal that can be taken up. Once they start getting clogged up, you get a lot of problems. And that happens a lot at our large competitions like South's Best. I hear about it happening at Jubilee Best as well. Yeah, so that is an important thing to think about. If you're having problems, maybe look at your Wi-Fi situation in your home or in your school. Make sure everyone doesn't have their phone hotspot on, things like that. It does plug in with USB, and it goes in. It's pretty self-explanatory. We'll talk more about how you plug those in the second video when we talk about how everything goes together. Next up is the screw terminal interface. And this picture I have is kind of blurry, so I'm going to switch over to my full screen camera so you can kind of see what that looks like. It is a 3-wire cable going to a 3-port screw terminal. So a screw terminal is a type of terminal. The word terminal is sort of things coming together. So a screw terminal basically uses these little flathead screws. Some of your hubs might give you a small flathead screwdriver that fits in those, but it uses these flathead screws that screw down and push onto the wire. And you know, the wires, most of the wires that go into them have these nice flat pieces there. I know it's blurry, but hopefully you get the point. It has these flat pieces that work really well with those rather than just a loose bundle of wire. This particular one, the 3-wire screw terminal interface cable, this is specifically for use only with sensors, potentiometers, limit switches, the IR sensors. So sensors, it's a general category. We're going to talk about all the different sensors you can use. There is a different one for the motors. We'll talk more about it, more specifically about how you plug these in and how you plug in the motors in the next video. Next up, of course, is motors. Motors are pretty self-explanatory. If you don't already know what a motor is, that's fine. A motor is essentially a device that uses electricity to turn. So you're going to put in a voltage to it, and it's going to turn a certain speed, a certain strength, things like that. The best robotics motors do have these gearboxes in them that make them stronger, but also make them slower. However, they are really robust motors. They don't really break easily. However, it is easy to drop them, especially if you drop them on the shaft, which is this part that you plug things into. They can still break, especially with the gearbox. The gearbox can be replaced. I'm sure your best hub can help you with that, but try not to do that. So this here is a small motor. These are good for things like arms, claws. They can control your wheels if you want to save your large motor for something else. They are totally capable. They just may not be as powerful or as fast, things like that. This is what the large motors look like. I have them on this little test bed we'll talk more about in the next video. But these are what the large motors look like. They're a lot more powerful and a little bit faster. So that is something to think about when you're designing your robot. You want to think about which motors you have. You have 2 of each, how you can use those, things like that. Let me move my stuff around here. So yeah, an important thing about the motors is that they do require motor controllers, which I think might be the next slide, but I'll show you. This is what the motor controller looks like. Yeah, so a little bit more on motors. The preferred method of connecting wires to them is soldering. If you don't have any experience with soldering, ask your teacher. Maybe you've got a shop in your school, things like that. It is much better to solder them, because if you try to connect it any other way, it can come disconnected during a match. So it is important to think about that, both when you're designing a robot and also when you are just putting it together. We'll talk a little bit more about different ways you can connect it in the next video, but I do highly recommend soldering it. That is one of the few things you're allowed to do with your returnable kit. I haven't said it yet, but pretty much everything in the returnable kit cannot be modified. It cannot be drilled into, screwed into, glued, things like that. You can only use painter's tape on it, things like that. But that is one of the exceptions, is you can solder wires to your motor. It is preferred that you unsolder them before returning them to your hub. However, You know, that's just something to think about. Another thing to think about with the motors is that polarity is not marked. So polarity is essentially your plus minus. You always see positive, negative on electrical devices. And that is because it sort of doesn't matter. Almost every single motor in the world today doesn't matter which direction, other than it's going to change which direction it spins. So it can be something you experiment with. It can be something you can fix in programming, and I'll show you how if you've already soldered it. I'm going to show you in the next video how to sort of build this little test robot, and you can figure out which direction it spins. Maybe you can label them with a piece of tape or something, piece of painter's tape, of course. But yeah, so polarity doesn't matter a ton, other than that it changes the direction. So maybe you've already written your program and you have a soldering iron with you, and you realize something's not turning right at the competition. You can switch it around. So yeah, I do recommend using the VEX motor mounting kit that comes in your consumable kit. You can see how I did these mounts. They come as a flat piece, but they've got these sort of dotted line deals going on with them that you can bend along. Now how I bent that was I put it into a vise and just used a soft mallet to hammer it down. But there's a lot of different ways you can bend them. That's how I did it. Hopefully me moving it around on here shows you how that works. Let me switch back. Here we go. So yeah, I just realized we've missed the last couple slides. Let me show you. So there's the motor slide, screw terminal interface, USB tethers, controller, stuff like that. Okay. Next up is motor controllers. So I told you there was a slide coming up, and here it is. So the motor controller has to be in line with the motor. Basically what that means is you cannot plug your motors directly into the Cortex. There is a way to make that work, but I'm not going to tell you, because with these particular motors it will damage the Cortex. It will likely ruin the Cortex. So I'm not going to tell you how to do it. I shouldn't even tell you that the option's there, but I know you guys are bright, you're smart, you know not to mess with that. The motor controller is what you want to use with these motors. The reason there is a motor controller is because Best has motors that can plug directly in, because they've got the motor controller built in. Essentially what this motor controller does, though, is it receives a signal and power from the Cortex, and then it sort of gets that signal that tells it how much power to give to the battery. So essentially what it does is sort of act as like a dam holding back a river. So without this there, the whole river is going to crash through and hit the motor and damage the motor, and even the port that it's plugged into. So you want the motor controller in line with it. So again, it prevents damage. You can think of it as a safety net as well to protect the Cortex. I mentioned it's really expensive and they're hard to get, and you don't want to put your hub or your school in that situation. Something to note is that you can only plug these in to motor ports 2 through 9. Motor ports 1 and 10 are intended for a different device, and these will not plug into them, so don't try. You should not be using those ports 1 and 10 at all in Best Robotics, so don't worry about it. A quick little tip that I've learned in my many years of Best Robotics is that there are sort of 2 power banks you can think about in the Cortex. Essentially what this is the Cortex, just the circuit boards inside it route and share power between 2 different sets of ports. So motor ports 2 through 5 and motor ports 6 through 9 are the 2 banks. Each one gets 4 amps if you want to do some math of how strong your motor is, things like that. You can think about that. Yeah, but anyways, so basically what this all means for a beginner, someone who doesn't understand jumbo. I'm talking about you want to split your motors between these. So if you plug your motors into ports 2 and 3, they're going to be sharing power. So they're not going to be as strong. But if you plug 2 motors into ports 2 and 6, they're going to be on 2 separate power banks, and they're going to be getting the full amount. So you've got 4 motors, so you can think about splitting up and maybe putting a large motor and a small motor on ports 2 and 3, and a large motor and small motor on ports 6 and 7, things like that. And that is something I didn't know about when I was still a student competing in BEST, and I always noticed that sometimes the motors weren't as strong. Maybe the left wheel wouldn't turn as strongly as the right wheel, so that could potentially be the cause of it. So think about that. Your 3-wire motor connector. I don't have one sitting here. Here they are. I've sort of got a little apparatus over here. Let me switch over just to show you what it looks like. So the picture's a little blurry, and I won't forget to switch back this time, I promise. You've got this little 2 thing. Ignore the clips there. Those are something I use for something else. So yeah, it's just a 2-wire screw terminal interface. We talked about what that means earlier. But this diagram here, switch back. This diagram here shows you how it plugs into the motor controller, and it goes towards the motor. Again, I'll show you more details in the next video about how to plug that in. Yeah, so that's just a little more directions. Yeah, so not keyed just means that there's not something physically keeping you from plugging it in different ways. This is another place that you can reverse that polarity, and it's not going to hurt it, it's just going to change the direction. Another tip I offer is this connection is one that easily comes unplugged. So I highly recommend sticking some painter's tape on there, because that's the only tape you're allowed to use on this particular connection. So I do highly recommend taping those together, or finding some way to join them together to make sure they don't come unplugged during a competition. Next up is servo motors. So this is the second type of motor or the third type really, if you count BEST or large and small BEST motors. So servo motors, they have a lot less power in them, and part of that's because the power is used sort of in this sort of processing way. But servos essentially are good for things like claws or small actuators. Actuators are just things that move. They can't move a lot of weight, but if you use them smartly, you can, put them to good use, depending on what you're thinking about. So the first thing that always pops in my head is claws, because that's what I used them for when I was back in high school. But there's certainly more uses in that. Important thing to think about is it requires a servo power adapter, which looks like that's this bottom right picture here. It's sort of this block, this dark block. Essentially that just sort of converts the power coming out of the brain to the power and signal that the servo needs, because the servo operates like, what could you describe it as? Essentially it's less of a go forward, go backwards, and it's more like, hey, turn to this position. So that's something to think about. We'll talk more about that in the programming video, of how servos work and how you program them to move to the position. Something else to think about is that they do not turn continuously. They sort of turn, I think these ones are roughly 225 degrees. So not quite a full circle, but a good bit, maybe 270 degrees, something like that. But yeah, so that is something to think about when you're designing it. Make sure you move it around a little bit, and check that it is working. Your batteries, obviously a vital part of your robot. You don't really have a choice to use the battery. But the batteries, they use these little pigtail adapters. The one in the picture is different than what I have because at War Eagle BEST, we switch to a different connector that's easier to connect and disconnect. Those pigtail adapters, they are difficult to plug in and pull out. So please, please, please never try to yank it by the wire. I know in a lot of devices that works, even though it's not safe, it works. But with these, it is very possible for you to pull that out, pull the wires out. And if you pull those wires out, you create a really dangerous situation where you can shock yourself. You can short out the battery and cause it to smoke a little bit. These aren't as dangerous as LiPo batteries, but they can shock you and they can smoke if you short them out. So please, please, please unplug it and plug it in by the adapter. If your hub gives you these, I don't know what they're called, these red and black connectors, I highly recommend that you use them. And I'll show you how we use them with our Warrigal Best kits. Yeah, that's that. Another recommendation with these is that you always charge it in safe mode. I know when you're in a competition, it can be tempting to flick on fast mode, but on way too many unfortunate occasions, these have started fires. And I promise you, I'm not just making it up. It is dangerous, and especially because a lot of these batteries that your hub's going to have, that even we have at South's Best and Warrigal Best, they're older batteries. And these batteries, although they're a lot more robust and long-lasting than LiPo batteries, like the ones in cell phones and things like that, they can degrade. And if you try to pump a lot of power into them, it can cause some major problems. So please use safe mode all the time. It's really not that much slower than you would think. Fast mode essentially is going to heat up your battery and cause a lot long-lasting damage to it. So, and of course potentially cause fire. So please use safe mode. Pulleys and belts. I don't think I have one with me, but there's a picture there. So in your returnable kit, there's going to be a set of pulleys, there's belts. A lot of times you'll have some ball bearings and even some axles. A lot of times you get that roller blade wheel. All of these parts still apply. You cannot modify them. If something's wrong with them, and maybe a team that had it before you maybe modified it, just let your hub know, and I'm sure they have plenty of extra. But please do not modify them. This is something, I mentioned that your hub may have a lot of extra. That doesn't make it okay to do it, because when you go to get your robot inspected, if the inspector, which they will, when they see that you've modified it, they're going to make you take it off the robot. And I know belts and pulleys can play a really vital role in your robot. You can sort of use it to easily create sort of a gear ratio of getting more power or more speed based on what you need for your robot. So please, please, please don't modify them. However, there's one exception to this. I do have... So it comes with this closed belt. This closed belt, you cannot cut this or shorten it or anything. Don't try. This closed belt does not change. However, there's also a open belt. The open belt is essentially the same thing, but somebody has already cut it in one place. The open belt can be used for some different sort of sliding mechanisms. And if you are curious about that, I might make a video about it at some point later. But open belts can be cut because they're easily replaceable. But the closed belts, do not cut those, please. And if we notice that it is cut, you won't make it through inspection. So don't do that. A new thing that Best Robotics actually introduced last year was the IR sensor. I don't have one with me right now. I'm going to talk about it in a later video a lot more. But you can do several things with the IR sensors. You can use it for sort of beam breaking. So you think about, we'll pretend these are the IR sensors. You can put these, and if something passes between them, like my big head, it's going to send a signal. And you can program it to say, okay, when that beam is broken, move the arm up or something like that. You can also set up a simple line following program. I will definitely talk about that in the programming video. You can encode your wheels with it. Some of y'all might, if your school uses Alabama Science and Motion or AMSTI, and you take physics in high school, you might do one of those projects where you have the little car, and it's got sort of a ladder pattern on it, and what it has is an IR sensor, and each time that pattern goes by, it can record how fast it's moving. Essentially, you can do the same thing with your wheels if you're smart about how you do that. I'll talk about that in the programming video. You can also use it for communicating between different parts of your robot. It's not really necessary, but it is something that's used in the real world, as IR sensors can sort of kind of shoot SOS messages to each other, or it'd probably be some sort of binary code or something to communicate back and forth. So that's what IR sensors can do. Best Robotics does publish a full guide to the IR sensors because it is fairly new and a lot of teams are unfamiliar with using IR sensors. You can use this QR code. There's also that link, that short link, aub.ie/IR sensor. That's going to take you directly to Best Robotics website, where they tell you all about how to use it, how to program it, how to put it together, things like that. So yeah, you've heard me talk a lot about inputs on the Cortex. This is sort of a quick diagram. You've got your analog inputs. Your analog inputs are going to be used for things like potentiometers. There's limit switches, which, just to be clear, let me show you what those look like. I'm gonna grab. There we are. Sorry, I should have had this out already. So your potentiometers look like this. What is a potentiometer? It is a rotary encoder. So you turn it and it changes the signal. The way these particular ones work is you'll plug it into your analog port, and I'll show you how to wire it in the next video. But essentially what it does is it controls how much power goes back to the brain, and the brain says, okay, this percentage comes back, so that's how much it's turned. Your other type of sensor that goes in analog is the limit switch. So the limit switch is essentially a button. You can probably hear me clicking it. Hopefully it's not too annoying for you, but it's essentially a switch that controls it. It's sort of the same thing as a touch potentiometer electrically, except the fact that there's only sort of 0 and 1. Rather than being able to switch 20%, 30%, it's either no power is going back or all the power is going back. And again, I'll show you how to wire that in the next video. Your digital in and out ports aren't really used much in Best Robotics. Trying to think. I know there's at least one thing, but I'm drawing a blank right now. You can use your digital ports with the limit switch, actually, because digital is gonna work that way. But I can't think of anything else right now. In the next video, I'll update you if I am wrong about that. Of course, you've got your 3-wire servo and motor control on the motor ports. Switch back. Next up, this is a quick example connection. Again, we're going to talk about this more in the next video. So I'm going to kind of brush over this, but that is a sample connection you can look at. Servo mounting. This is what I want to talk about. So it's easy to look at your servo, and actually looking at this one, it's been damaged, so someone's done it wrong before. It's easy to look at that servo and say, oh look, there's holes, I'm going to put a screw through it. That's not really how we do it. If you just put a screw through it, it's probably going to break. These are really sensitive plastic parts on the servo. It is important that you don't break them, both for your sake and for your hub's sake, because servos, they're not deathly expensive, but they are a pain to get your hands on, and they aren't $0. So you get 4 servos per your kit. There should be the mounting hardware included. A lot of times you're going to get a brand new servo, and honestly, the reason is a lot of times teams will break the mounting horns. You want to be careful about that. So what you've got is these rubber grommets that you're going to stick on them, and you've got the little brass spacers. That's these little bits, these little guys. So those essentially are going to go in. I think I've got another slide showing that. So you stick those grommets on top, and then you stick the spacers through, and that is going to completely protect the plastic when you drill those screws in. It does come with those specific screws as well to use. They are small screws and easy to lose, so be careful about that. But those are there. So again, here's the slide. You're gonna stick the grommets on top, stick those spacers through, and then stick the screws through. This is a quick note on how to sync your or pair your controller and Cortex. You essentially plug it in like that. Again, I'm going to talk more about this in the second video, but if you don't get to it, this is that tip. Programming options. This is what our third video is going to focus on, but I will go ahead and tell you there are 3 main programming environments. That's Simulink, EasyC, and RobotC. Simulink is a graphical programming and modeling environment. It's primarily made for simulations. It's in the name. It is something that engineers use all the time, so it is a good thing to learn, especially in middle school and high school. And it does have that potential to see what your program's actually going to physically do. You can simulate it in a sort of limited capacity. EasyC is a block program environment. If you've done Lego Mindstorms, it is very similar to that. EasyC has a lot of issues with working with the VEX firmware, so I don't recommend using EasyC. RobotC uses the language C with a text editor. If you've ever programmed Arduinos, Raspberry Pis, things like that, this is essentially the same language, but it's got some custom things in there to work with the VEX platform a lot easier. One important thing with RobotC is it has runtime debugging. This means you can, if your robot is plugged in, you can step through your program to see what's actually happening in real time. Especially with autonomous portions like they added last year. This is really helpful. So I do recommend RobotC. It is easier to use. It does have a graphic, a block programming environment now as well. And that's actually what I'm going to show you in the third video. However, it is sort of my preferred method of teaching. So yeah, RobotC. You can download it at aub.ie/RobotC. You can also get it if you just Google RobotC download. It's not too hard to find. Again, it does have a graphical interface. I'm going to tell you, these are sort of some instructions on how you're going to get started once you turn that program on. So here's a couple tips I want to share in this video, and I'll probably reiterate them in the second and third videos. You want to make sure your robot is in a safe place, especially if you're testing a program. Using a jack stand is really simple. Basically, if you just have a 2x4 or something that you can sort of jack up your robot where the wheels aren't on the ground. That way you can still see them spin and make sure they're spinning the right way and things like that. If you're doing something like just testing electronics, like I built this little motor mount board. Heck, I could turn this into a robot if I wanted to, but what it's really for is testing the motors. So you want to think about having this sort of test bed to test your programs are on. Best Robotics, we love safety, so make sure team members aren't sticking their fingers in it while it's running, things like that. And I'm not going to run through all this stuff. A couple more tips. LED status lights on the controller can tell you a lot. So the top one is going to tell you the joystick's condition. It'll tell you the battery. Green means it's good, yellow means it's getting low, and red, of course, means it's dead. The robot will also tell you the battery status. The robot light will tell you that battery status based on the voltage the Cortex is getting, and it sort of communicates that with the controller. The VEXnet light is going to help you figure out whether or not you're connected. So if it's green, that means you're good, you're connected. Solid green means you're good. Yellow, it's usually blinking yellow, is telling you that it's searching. So the lights on the controller and the joystick are sort of the same thing. They all have the same meanings. It's just two different places you can look. So that's that. Some tips, some more general tips I want to share, and I'll probably reiterate this. When you're soldering, let me show you. When you're connecting your motor wires to the servo, I mentioned that these, the ones that are used for sensors and things like that, have these nice, fancy, sort of flat tips, and it's difficult to use those sort of frayed stranded wires in them. So it's really great to sort of tin them with solder. What that essentially means is you heat it up and put a little bit of solder on the wires, and that's going to sort of create this one solid connection. That makes it a lot easier. It makes it a lot easier to not accidentally short things out. Do want to remind you, the only place you can solder is on sensors and motors. You should not be soldering any of these wires. You should not be soldering any of these VEX wires, the colored ones, things like that. You do have a set of red and black wires that comes in your consumable kit that you can solder. Sensor cables, servo adapter cables, things like that, they're all keyed so that you can only insert them in the correct direction. And again, what I said earlier about things being keyed, what it means is that there's sort of this little slot on it that prevents you from plugging it in the wrong way. So just be careful when you're plugging things in and don't force it in backwards. Just turn it around if it's not going in. Always be sure that you tighten the screws on your screw terminals. That is something you can check right before a match or something like that. And just grab your screwdriver and tighten everything. As far as mounting your Cortex goes, we highly recommend using number 8 screws through the holes. Be careful not to over tighten them because you can crack the plastic. Another way I see a lot of teams do is literally just sticking zip ties through a hole in the robot. That is perfectly acceptable. As long as it's secure, you're good. You can't tape it. That is not secure. But if you use zip ties and you tighten them, you should be fine. Hot insertion of USB keys is another issue that we have sometimes. Essentially what that means is plugging in your USB stick while the robot is already on or the controller is already on. That can cause issues. It can short things out. Final note, you are allowed to operate tethered with a USB cable in BEST Robotics. Now keep in mind, you have to stay in your driver box. So that tether cable is maybe 4 feet, 3 feet, 6 feet. It's not very long. You're not going to get a lot done. So if you have problems with the USB keys, talk to your hub and try and get it figured out. If they're broken, they can get them replaced for you. I really hate to see teams that have to do that in competitions because it really limits what you can do and it sort of dampens the fun. So that's something to think about. I'm not going to read all this. This is how you calibrate your joystick. Calibration essentially just means it tells the controller what 0 is. So, when you let go, the springs pull it back to the center. And sometimes that cannot line up with what it thinks is 0. So this is the instructions for that. So I'm going to skip through here. Those are all things I'm going to cover in my programming video. But the BEST Generic Kit User Guide is a super useful tool to help you with pretty much everything I've talked about in here and everything that I'm going to cover in the next few videos. This guide, it's an older guide, but it still applies because it's the same hardware. You can follow this link, scan this QR code. I recommend this as the #1 place you check when you can't figure something out related to hardware or plugging things in or something's just not working. It's got examples. It shows you where to find example code, things like that. So I highly recommend this. It's a really great resource. And I have a couple more in a few slides on this slide. So these are all some links. I'm gonna post this PowerPoint as a PDF in the description of this video on YouTube, so you can pull these up and get these links. Don't worry about typing them in. I'll also stick the links in the description itself, so you don't even have to open the PowerPoint, but it'll all be there. These are a couple good resources to use if you are ever stuck. So that wraps up this portion of our 3 videos. So hopefully you learned something. Hopefully you've got a better idea of where to start. Again, this is part of a 3-video series, so stick around. I should have a little link here showing you how to get to the next video. And if it's not already posted, just give me a few days and it'll be up. So yeah, thanks for watching. If you haven't heard of SCORE before, you can check out our website at scoreu.org. You can learn about some of the programs we do. Of course, one of them is Best Robotics. I wish everyone a great season this year. I know things are tough with COVID going on, and some people are having remote competitions, classroom ones. But good luck this year. Stay safe, and I hope you really enjoy this season, despite everything that's going on.